Alright, so now we're going to talk about u substitution. Okay, so have those notes, print them out, and read through them first. We talk about, all right, well, we know the simple power rule, but now what if we have to integrate? The very last one we looked at in the power rule, we had something outside of parentheses you could distribute, okay? But what if you have a power other than 1 on that parenthesis, okay? If you do, you want to try u substitution. That won't always work. We're going to look at several different things to try, but this section will look at all u substitution. Okay, so I'd love to be able to distribute that 2x, but the problem is I can't because this is a fourth power and not a first power. So when you have this case, what you want to do is say, all right, first thing I want to do is try to find u. We let u be the inside of the parentheses. So u would be x squared plus 1. Okay, and then immediately next you want to find du. Du is the derivative of u. So what's the derivative of x squared plus 1? It's just 2x. Okay, now we want to do our substitution, okay, and make sure that we have this. We call this u, right? So that becomes u to the fourth. Okay, now I need du. du is 2x, and I'm sorry, I should have written a dx there and I did it. Okay, du is 2x dx. Do I have that? Well, yeah, look at what I have here, 2x dx. Okay, so now I can fill in du. So you want a u, and then you want to make sure you have du. Sometimes you don't have everything you need for du, and that's what we'll talk about. How do you get it? Okay, and now what you want to do is just integrate this like we did whole last video. You want to add 1 to it, divide by the new power. So this would be 1/5 u to the 5th plus c. Now the problem is we started in x's, so we can't end in u's. So your very last step is you're going to replace u with what u is from over here. So the answer is 1/5 x squared plus 1 to the 5th plus c. Okay, so find u, find du, make sure you have it, and then you can integrate it like normal. Just don't forget to go back and put the x's in instead of the u's. Okay, alright, so integral of 2x plus 1 times x squared plus x dx. Now, I don't really like this one. What you could do is are there any powers other than 1 on those parentheses? No, you could FOIL that out and you could integrate it separately, okay? We'll do a u substitution, okay? Because this one has higher powers, I'm going to let that one be my u, and I'll show you why. Because if I let that be u, then what is du? Derivative of x squared plus x would be 2x plus 1, which is exactly what I got right there. So now replace it. We're going to take this out as u, and it would be a first power. And then this part becomes du. And again, I'm real bad about always forgetting my dx there. So now I can integrate this u to the first power. Add 1 to it, divide by the new power, and I would get 1/2 u squared plus c, and switch it back to x's. 1/2 x squared plus x squared. Don't forget, this power has to come down and be in my answer, plus c. Okay, now let's keep going, looking at some more. They're going to get a little bit harder as we go along. Integral of 3x squared times the square root of x cubed minus 2 dx. All right, the very first thing I'm going to do is anytime you see a radical, we want to rewrite it. So square root would be 1/2 power. Okay, so again, we let u be the inside of the parentheses. So then du would be the derivative of that, which would be 3x squared dx. Okay, and I copied it down wrong from here to here. There was a 2 right there. Okay, so let's do our replacement. We're taking out this as u to the 1/2. Now I need du. du is 3x squared dx. Do I have that? Yeah, here's 3x squared dx. So then that knocks out as du. And then let's do our power rule. Add 1, which I'm going to write 2 over 2. So my new power is 3 over 2. Dividing by 3 over 2, same as multiplying by 2/3. So 2/3 u to the 3/2 plus c. And I'm going to replace that. 2/3 x cubed minus 2 to the 3/2 plus c. Okay. All right. Number 4. Integral of negative 4x over 1 minus 2x squared squared dx. Alright, so I can't integrate it with this parenthesis on the bottom. So what you're going to do is move this parenthesis to the top. So if it was a positive 2 second power on the bottom, it's going to, when you bring it up, be to the negative second power. And then, here we go, when I have parentheses to a power, I'm going to try u substitution. So we'll let u be the inside. So that would make du, the derivative of that, which would be negative 4x dx, which is what I have, so it makes me feel good. So this comes out as u to the negative 2. And then du is negative 4x dx, which is exactly what I have, so that comes out and becomes du. I replaced everything. So if I add 1 to it, I get a new power of negative 1. So I get a negative u to the negative 1. Now, negative exponents we know are not okay. So a negative 1 over u plus c, and of course we have to replace it. Negative 1 over u, which is 1 minus 2x squared plus c. Okay. Alright, so now, sometimes we don't have what we need for du. If it's just off by a constant, by a number, then I'm good. If I'm off by an x, then I can't do u substitution. I have to do a whole nother method. But let's do some that are just off by a number. Alright, integral of x times 3 minus 4x squared squared dx. Alright, so if I did my u substitution, u would be 3 minus 4x squared. Alright, and the derivative of that would be negative 8x dx. So let's start replacing. This becomes u squared. Okay, now if I have a u, I need that du. But du is negative 8x dx. Do I have that? No, I only have x dx. So if you're just off by a number, no big deal. Add in what you need. Okay, but now in math, you have to balance that out. If you stick in a negative 8, you got to cancel it on the outside with the reciprocal, a negative 1 over 8, because if you were to multiply that in blue, those cancel out to be a positive 1. Okay, I can change things by a positive 1, I just can't all of a sudden stick in a number in. So if you put a number in, you balance it out on the outside with the reciprocal. So this negative 1/8 is going to come down here. And now this negative 8x dx becomes du. Okay, so I have negative 1/8 u squared that I need to integrate. Alright, so if I add 1 to it, what new power do I get? 3. I don't want to write this because I already have that fraction. So dividing by 3 is the same as multiplying by 1/3. So I get negative 1 over 24 u cubed plus c, or negative 1 over 24. Replace that u with 3 minus 4x squared cubed plus c. Alright, let's do another one of those. Okay. Integral of 7x squared times the square root of x cubed plus 1 dx. Alright, so first thing I'm going to do is rewrite it to the 1/2 power. Alright, so u would be x cubed plus 1. So then du would be 3x squared dx, right? Alright, so let's do our replacing. That comes out, that's gone, that's u to 1/2. Okay, now du is 3x squared dx, and what do I have? I have 7x squared dx. So, one thing you can do is if you don't like that number in the front, pull it out, okay? And say, alright, I have now x squared dx, and what I need is 3x squared dx. So if I stick in a 3, I have to balance that out, so the reciprocal of 3 is 1/3. So now you can multiply that outside, and so you can call this 7/3. All right, and now u to the 3x squared dx becomes du. So we have 7/3 u to the 1/2. So let's integrate it. So if I add 1 to it, I get a new power of 3/2. Dividing by 3/2 is the same as multiplying by 2/3. So I'm left with 14/9 u to the 3/2 plus c, or 14/9, what's u? X cubed plus 1 to the 3/2 plus c. All right, here we go. Number 7. Integral of 5x over 4 minus 3x squared cubed. All right, so first thing we do, bring it up to the negative 3 power. All right, so u would be 4 minus 3x squared. So du would be the derivative of that, which would be negative 6x dx. I can see right now I don't have that. So first thing I'll do is get rid of that 5. Put the 5 on the outside. Okay, just make sure that's a prettier x. Okay, so this is going to be my new u. And then I need negative 6x dx, and I don't have that. So if I stick in a negative 6, then you need to balance it out with the reciprocal of negative 1/6 on the outside. And you can multiply those. So we end up with a negative 5/6. And then this now is du. So let's write negative 5/6 u to the negative 3. We want to add 1 to it. And I get a negative 4. Nope, I don't. I get a negative 2. Sorry. Dividing by negative 2 is the same as multiplying by negative 1/2. So the negatives cancel, and I'll be left with 5/12 u to the negative 2 plus c, or 5/12 4 minus 3x squared to the negative 2 plus c. And that's not okay. Fix it. You already have a 5 on top and 12 on the bottom, then drop that to the bottom. Fix any negative exponents. And last one. Integral of x times 3x squared plus 2 to the 4th dx. No rewriting. So u is just 3x squared plus 2. du is just 6x. So that's u to the 4th. I need 6x dx, so I need a 6. So cancel it out. And then now I can knock that out as my du. And then if I add 1 to it, I get 5. Dividing by 5 is the same as multiplying by 1/5. So I get 1/30 u to the 5th, or 1/30, replace it. 3x squared plus 2 to the 5th plus c. And we'll look at some more u substitution next time.